So what you say? I'm gonna show you on the board first before I give you any value, right? I will try to use the values that on your formula sheet, so you don't really have to remember too much things. Actually, I'll show you both sets because sometimes they'll give you a different form. So I wanted to imagine a situation, right? A popular one that I use is, imagine you want to find out what is something that affects a student's grade in applying. What do y'all think? What is something that would affect a student's grade in applying?
SB.
Huh?
SB.
A high SBA mark? All right. All right. So let's check out how SBA marks affect the grade. That's what score, right? Score in applied. If I want to investigate this, right? Which one is the dependent variable? Dependent. The score. So the score is the dependent variable. And the SBA marks is the independent variable, right? Is the independent variable. So I want to see how basically this affects this. Okay. So I might do something like this. I might go around, collect some marks, some SBA marks, and then ask them what was the final score in apply. Right? So you might have your SBA marks. Your SBA marks is your independent variable. And here is the score. Right? And you might get things like this. People with a high SBA mark might get a high score. So you might end up with some values that looking like this. If you were to draw a best fit line, what you came up with here is a regression line. That's a regression line, right? That regression line could allow you to do a few things. You can have your score. You could predict your score based on, let's say, the y-intercept is somewhere here. Based on your y-intercept and based on your SBA and some gradient. So if I plot my graph and I get my gradient and I get my y-intercept, and I can easily put in an SBA score here and find the final score, right? This is technically what a regression does. It takes your independent variable and allows you to predict by creating a regression equation or regression line. It allows you to predict a score, right? So what you have to do, of course, take your values, plot your values, but you have to be able to find this. We call this the regression coefficients, but we use a different letter. But we call this the regression coefficients, technically a gradient, and then your y-intercept is when your SBA value is 0 or it's points. Right? So what we're going to learn now is going to learn how to develop these equations. All right? Right? So technical regression line is like a predictor for one variable. Later on, if you're going to do more applied, well, more statistics, you could use more than one variable. So you could use score, you could use amount of time studying, you could use amount of time lineman, if people is affect you, all them things. Right? Lineman with your girlfriend too much, all them things is affect you. Could, we don't know. Right? So those are multiple regression. These are simple linear regression with just one variable. All right. So what we have to learn to do now is to learn to set up how to get those values, how to predict those values. Most people use these things in ASP because you can see how simple it is, right? Right? Calculations can be a little tedious because if you have plenty values, then it's a little bit, it's a lot to calculate. Right? Before I move on to anything, look at these values. Look at these 5 different graphs. So look at these 5 different graphs. You all remember proportionality, positively and negatively related. Look at the first graph and the last graph and the graph in the middle. What you can see about the first graph, how are those values related? Positively or negatively? Negatively, right? One, you'll recognize that they are slope negative. So it means that they are inversely related. When one gets big, the next one's small. What about the last graph? Positively, right? One gets big, the next gets big. What about the one in the middle? Did you say anything? Nah. Now I'm kind of mad. Right? So they can't really tell any relationship there. So those relationships are defined by a word that you'll say on top. The word is correlation. Right? So together with regression, you can also find correlation. So for example, the first graph has a correlation of -1. And the last graph a correlation of 1. What do you think the middle graph is? Correlation of what? 0. Right? You can't really say anything about that graph in the middle. All right? So it's important that you can watch the graph and do that calculation as well. It's called an R value. And the R value shows correlation. If your R value is more than 0, positive, less than 0, negative, correlated. Right? And of course, your value cannot be bigger than 1 or less than minus. All right? Nice. So we will do those calculations in a little while. But if you look here, here we have our regression line. Least squares regression line is a line of y on x, and it's written just like this. Don't worry with this too much. That is your regression line, right? Y is your dependent variable, x is your independent variable. B is your what? B is your regression coefficients, or sometimes called gradients, and A is your what? A is the intercept, right? A is your y naught value. Are you okay with that? So the trick now is how do we find it? Right? Your graphs can also be x on y, so you want to pay attention to what they say, right? And if you look here, these are the first set of formulas that you need to find it, right? SXX, SSY, and so on. These you have to learn. These are not on your formula sheet. I'll show you the ones on your formula sheet later on. Okay? And then you have the big S format. You normally use the small s, right? And if you look here, it tells you how to find B. B is SXY over SXX. That's the calculation, right? The formula sheet, I'm going to show you the formula sheet has a different formula. All right. After you find B, it's very easy to find A because you're using Y bar and X bar to find E. And you beat value. Right? What we assuming in applied, we assume that X bar and Y bar always on your graph, always on your line. So that's why we're using X bar and Y bar here. If I ask you to draw a regression line, you're not just drawing a best fit line. You're drawing a best fit line that passes through X bar, Y bar. Have to. All right. So when I say plots, and you might need graph paper, but we'll try to escape today without graph paper. When I say plots, you're plotting points. When you do a regression line, you have to have X bar, Y bar. Okay. All right. Do me a favor. Write on this first. Least square regression of X and Y. Write down this first and the formula. Then I will go back and show you how to find SXY. All right, online. So basically, it's just a bunch of formulas, but I need to understand how to interpret it, right? Carry me to the art of focus. I don't know how it's come up with my feet, boy. Name Lucas. Gusto de preguntar lagi.
Nasa sawa.
Ha?
Sawa.
TikTok. TikTok. Just one that ideas making you work around.
Same as my person.
Huh? I think doesn't. I don't know how he'd be on my feet. Ayat lang. Adan? Kaya lang partner.
Well, I think most. Yes.
You're done? Right, so let's try one now. Right, what's this one here? This is 2000 and something, I can't find. Right? But we could use the formula I just used, I just gave you, right? I'll show you the ones in the in your book later on, in your formula sheet later on. Sales persons at a certain establishment are required to write down the values, right? Salespersons at a certain establishment are required to take an aptitude test before starting the job. 6 months later, they are given a score based on their performance. For a sample of 10 such workers, their score on the aptitude test X and their corresponding performance Y was given. So you have sum of X, sum of Y, sum of XY, X squared, and so on, right? Obtain the regression calculation for Y on X. So we already know they already give us the equation. So what do we need to get first? We need to find X bar, we need to find Y bar, and then use the formula I showed you to find Y, right? What's the one I gave you to find Y? That's what? Sorry, B, define B. SXY over SXX. So you have to go and find SXY using the formula I gave you and SXX. Right? And then when you find B, find A. A is equal to Y bar minus B X bar. Alright, so let's try that first now. No. No, the ones in the formula sheet look like this. Hope I don't lose this now. Write it down in case I lose this. Alright. Alright. No. Here I learn this and I just give the reason I mean I started writing SXX because one of the years they give it SXX. All the other years just give it to you like this. So I say, you know what, to be safe, let's take two closures. Alright. Right, go ahead now find X bar, find Y bar, find B and then E. Online, I would like you to message those four answers, right? Especially Kaylee, especially Kaylee, Keshav, and Ridwan, you number one on the list. Right, I'm on over 24 here. Hey, but my charger. Yeah, be interested.
Yeah.
That's one of the people came from. But one is, well, Mr. Mamo, I tell you, once it's clear, like that. Not really fine as exact, but yeah, all the time. Like a beer, as it's trying to give it to you, it's less than 600. Well, all right. So he didn't do it, I see you before, I probably follow. So you get this 3 months though. This not easy. I have Katie send the whole thing already, yes, so wait, none of them. People are getting the same thing on Katie. Oh, you think she used ChatGPT? No, no, Kelly wouldn't do that. Not Kelly. Sebastian get 0.59 and 7.457. Kelly got 7.56 and 0.587. Close. What you have? No, no. But it's just summer X, right?
Yeah, I buy my phone on us.
Hmm?
At least. Yeah, but already. But it's not my. No, I cannot do that. There's only us. So like when they come out, you want to put this, but I thought they said, I buy mine then, and it would be good. Go on to that. Well, if you can model, they have the model. Okay. So we get now, you get like the signal, but the not reaching that. Yeah, 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 the US, the US, I think 6 minutes, 62. Right, okay. Make sure I have on top, that they, what that. Yeah, but. This, no, they probably want to sell it. That things that when companies don't they buy the phone and that's not about the. For me, that's a lot of thing. Is reach, no web source. It will reach in web source, but the company people is about background. Say you want the 1 week focus. But so let's say very like, well, just something. Yeah, we find it's like get after it's like that.
Quality for again. Sxy, right? This is sum of xy and n over. Let's try that problem. Now, I know square enough. But let's write these values. See how we our Newton board, right? Right, you want to estimate the performance after. So part two, I want to estimate when the active score is 37. They want you to see what B is. Interpret B and we'll also interpret E. Then show correlation of it, right? Right? So you just help me with these values here. So you want to get Sxy first, sum of xy. So the sum of xy is this 11,305 on n and what's how much? 10. What was x bar? X bar would have been 37.7 and y bar would have been 29.7. Yeah. Right. So that would be 37.7 multiplied by 29.7. How much is that? 10.81. Yeah. And then here, sum of x squared, that was 14397 all over 10 minus 37.7 squared. How much is that? 18.41. So to find B, we know B is Sxy over Sxx. Sxy was 10.81 and this is 18.41. How much is that? 0.59. Now to get A, I'm using this formula here. A is y bar minus bx bar. Y bar was 29.7. B is 0.59. And x bar is 37.7. And we got how much? 7.4. So therefore, y is equal to 7.46 plus 0.59x. Right? So just fix the formula if the thing was wrong, right? Well, let's show yourself twice. Anyway, don't worry about that. And then part two now, part two, they want us to estimate y. So y will be 7.46 plus 0.59 by 37. How much hours? That's part two. How much? 29.7. Right. We need to understand some values now. What does A mean? A is 7.46. A, regardless of whatever x and y is, A is the value for y, value of y when x is 0. Right? So based on the scenario wherever the performance was based on the aptitude score, right? So when the aptitude score is 0, your performance is y. That's what this value is. Okay? But what about the value b? What does 0.59 mean? What does that tell you in words? What does this value in the formula tell you? Any ideas? Here, what do you think? Did you do it already? Very good. That's it, right? So for every unit increase in what, for every unit increase in x, or every unit change in x, y will increase by a factor of 0.59. That's okay? Right? So for every unit increase in x, y will increase by a factor of 0.59. Right? So as I said, you can learn these formulas, or you could go to your formula sheet where you don't have to learn anything, and you can use this set of formulas here. So if you look here, these are your formulas for correlation and regression. Right? So you can learn these formulas here. I mean, you can use these formulas here. So there's no need for you to necessarily go and learn SXY until. Right? They don't always give it to you in that form. Right? But just learn that B is SXY over SXX. Right? Whenever there's Y on X. Do we have time to do X on Y? All right. So I introduced this. Those who do the SB with me, there's something that we do it. So I kind of wanted to do this before we start the SB. So now that we did, I will put a sample SB and let's try and see if we can do up till here. All right. That's it. Right. Once we start back, we will just review this, do the other way around, X on Y and the correlation. And then we have hypothesis testing to do that will take us a few classes.